You are going to learn the selection sort algorithm in this video from Joyce Tech. I am going to explain the selection sort algorithm to you in such a way that it will become difficult to forget for a very long time. But let me first tell you how the selection sort algorithm works. All it does is that it picks the minimum element from the unsorted part of the array and places that element in the beginning of that array. That's it. Made sense? No? Don't worry. Let's deep dive directly into practically understanding the selection sort algorithm. So this is the array that we are going to sort using the selection sort algorithm. The selection sort algorithm also works in the form of passes like the bubble sort algorithm, which by the way, if you want to learn, then the link to the video is in the I button. Now let's start with pass 1. So pass 1 is going to start from this element, which means the element at index 0 of the array, and is going to continue till the last element of the array. That means the element at the last index of the array. Everything is going to make sense in a while. Just stay with me. Currently, you can see this entire array is unsorted. So what happens in pass 1 is we'll first find the minimum element from this unsorted array. So for that, let me declare a variable and I'm going to call it m_idx and I'm going to initialize it to 0. So now we compare the value at index midx. Midx is 0. So we compare the value at index 0, which is 66, which also happens to be the first element of this array, against the element at index 1, which is the second element of the array and which is 27. So between 66 and 27, which is smaller? 27 obviously. So now the value of the variable m_idx will become 1, which is the index at which 27 resides. Okay, and this means that the minimum element as of now resides at index 1 of the array. Now we move to the third element of the array, which is index 2. We compare the value at index m_idx, which is 27, against the element at index 2, which is 13. So 13 is smaller between 13 and 27. So the midx variable will now hold 2, which means the minimum element so far resides at index 2. Okay, now we move to the fourth element, which is index 3 of this array. Here we have 23. We compare it against 13, which is the element at index midx, all right, which is 2. So between 13 and 23, obviously 13 is smaller, 23 is not smaller, so nothing happens over here. The value of midx stays 2. Then we move to this last element of the array, which is at index 4. Here we have 10. We compare it against the element which resides at index midx, which is 2. So between 13 and 10, which one is smaller? 10 obviously. So the value of midx variable now becomes 4. And this means that the minimum element resides at index 4. Alright, after traversing the whole array in pass 1, we have found out that the minimum element of the array resides at index 4, which is 10. All these steps we performed in pass 1 were to find the minimum value or the minimum element of this entire array. Now, since we have found out the index holding the minimum value, all we are going to do is swap the value at index 4 with the value at index 0. Basically what we are doing is placing the minimum element in the first position of the array, and that's what I told you about insertion sort, if you remember at the beginning. So let's do the exchange. So 10 will come over here and this cell will hold 66. Alright, so this array is the output of pass 1. Now let me tell you a very interesting thing. Within this array only, the insertion sort algorithm has formed 2 subarrays. Since we have found the minimum element that has already been placed at the first position, hence this element alone forms a subarray, which is the sorted subarray, and the rest of the elements form the unsorted subarray. The good part is that we have to execute the further passes on the unsorted subarrays only. Initially, there was no sorted array and the entire array was an unsorted subarray. So we started from the first element, but after pass 1, we have got two subarrays now. It will make more sense with further passes, so hang in there. Now we begin pass 2. The midx variable will now hold the index 1 because that's the first element of the unsorted subarray now. Okay. Now the element at the midx variable will be compared against the element at index 2, which is the second element of the unsorted subarray. So 27 will be compared against 13. Now since 13 is smaller, hence the midx variable will now contain 2, which means of this unsorted subarray, so far the minimum element resides at index 2. Now the element at the index stored in midx will be compared against the next element of this unsorted subarray, which means the element at index 3. So between 13 and 23, which is a smaller? 13. So no change occurs to the midx variable now. Alright. Now 13 gets compared with the next element of the unsorted subarray, which also happens to be the last element. That is the element at index 4, which is 66. So between 13 and 66, obviously 13 is smaller and it's on the left hand side. So no change happens to the midx variable. That means after all the iterations of pass 2, the midx variable contains 2. That means the minimum element of this unsorted subarray resides at index 2. What we do now? We place the minimum element in the first position of the unsorted subarray, which is this index 1. Okay. And the element at this index, which is 27, will be shifted to index 2. This is the same type of swap we did in pass 1. So let's do this. So it will be 13 over here at index 1 and 27 over here at index 2. Alright, now what we did in the big picture was find the second smallest element and have placed it in the second position of the array. So now the sorted subarray stretches to these two elements and the remaining elements are part of the unsorted subarray now. Let's do pass 3. So we have 3 elements in the unsorted subarray. The value of midx, the initial value of midx variable will become 2 because that's the first element of the unsorted subarray. Here we have 27, which will be compared against the next element of the unsorted subarray, which is at index 3, which is 23. So between 23 and 27, which is smaller? 23. Alright. So what will happen? We are going to assign 3 to the midx variable. Okay. That means so far the smallest value of this unsorted subarray resides at index 3. Now what we are going to do? We are going to compare 23, which is the value at the index midx, against the next element of the unsorted subarray, which also happens to be the last element of the unsorted subarray at index 4. So between 23 and 66, 23 is smaller and it's obviously on the left hand side. So no change happens to midx variable. So after all the iterations of pass 3 are over, we have got our minimum element which resides at index 3. What we are going to do, like earlier passes, we are going to swap 23 with 27. Basically, we'll be placing 23 at the first position of this unsorted subarray. So let's do the exchange. So it will be 23 over here and 27 over here. Okay, so now in the big picture, we have got our third smallest element and it has been placed at its correct position. So now the sorted subarray stretches to these 3 elements and the remaining elements form the unsorted subarray. Notice that the unsorted subarray is shrinking with every pass. Let's do pass 4. Now we have only 2 elements in the unsorted subarray. The midx variable will be initialized to 3 because that's the index of the first element of the unsorted subarray. So the element that we have at index 3 is 27. It will be compared against the next element of the unsorted subarray, which also happens to be the final element of the unsorted subarray at index 4. Since 27 is smaller than 66 and it's on the left hand side, nothing happens. No change happens to MIDX variable. So we do not have any more elements in the unsorted subarray. That means pass 4 is over. One exciting thing that has happened is the minimum element from this unsorted subarray is already at the first position of the unsorted subarray. So no swap happens in this pass 4. And the sorted subarray stretches to these 4 elements. So after pass 4, we have the sorted subarray containing 4 out of 5 elements, making it obvious that the 5th element is at its correct position. So we can say that after pass 4, we have got this entire array sorted. Let's now write the selection sort algorithm. So we know that when we have 5 elements, then the number of passes is 4. So for any n, the number of passes is n minus 1. So let's write the outer for loop of this algorithm first. So it will be for within brackets I equals to 0 semicolon I less than n minus 1 semicolon I plus plus. Let me change this one. So in the programming world, when we operate on an array, it's always safe to start from 0 because that's the first index. Hence, I has been initialized to 0 and runs till less than n minus 1. So when n is 5, the iterations are 0, 1, 2, and 3. That's 4 passes. And these values of I will help us further as well. How? You will see it just now. Now we'll declare the MIDX variable. So it will be int m underscore IDX. But what we are going to initialize it to? So if you remember, in all the passes, it was the first index of the unsorted subarray which we initialized the MIDX variable to. So the first index of the unsorted subarray will be represented by I. So we are going to initialize the MIDX variable to I. Now there has to be an inner for loop which will run through the unsorted subarray, within which we'll write the code for comparison. So it will be for within brackets, it will be j equals to I plus 1 semicolon j less than n semicolon j plus plus. Let me change the case of I. So why j is I plus 1? Because if you recall, then the comparison starts from the second cell of every unsorted subarray. Thus, j starts from I plus 1. And every time the comparison would happen with every cell of the unsorted subarray. So this inner loop will run till the last element of the unsorted subarray. Hence, j is less than n. Now within this for loop, we'll write if within brackets arr, which is our array, within square brackets MIDX greater than arr j. All right. And if the condition satisfies, then we are going to assign j to MIDX variable. All right. So this code will check if the element at index MIDX is greater than the element at index j. If so, then the value of j will be assigned to MIDX, just like we did it throughout. And out of the inner for loop, we'll write the code to place the element at MIDX at the first position of the unsorted subarray. So it will be a temp variable equals to arr MIDX. And in the next line, it will be arr MIDX, which is going to get the value of arr I. And the last line of code will be arr I getting the value from the temp variable. And this is it. We have just written the selection sort algorithm. And with this, we have come to the end of this video of the selection sort algorithm. I hope you enjoyed learning the selection sort algorithm from Joey's Tech. Do share this video with your colleagues and friends. I look forward to helping you with programming and algorithms. And only for this video, goodbye and take very good care of yourself.